Mayday, mayday! This is the Celestial Voyager. Engines are offline. Repeat, engines are offline. We're caught in the gravitational pull of a black hole. Coordinates. Transmitting now.
Imagine a place where the very fabric of reality begins to tear apart, where time slows to a crawl, and the forces of nature are pushed to their absolute limits. Now imagine hurtling toward it, at faster-than-light speeds. We're about to embark on a journey through the heart of a black hole, where the laws of physics as we know them no longer apply. Buckle up, because this isn't just a trip to the edge of the universe. This is a voyage into the unknown, where impossible becomes possible. Are you ready to defy everything you thought you knew about space, time, and the very nature of reality itself? As our warp ship hurtles through the vast expanse of space, we approach a black hole. Its gravitational pull impossible to ignore, its presence both captivating and terrifying. A massive celestial object bending the very fabric of space-time, calling us closer to its event horizon, the point where no return is possible. The intense gravity distorts the space around us, warping time and energy. The accretion disk swirls violently, emitting a glow as matter spirals inward, doomed to meet its fate. We begin to realize this is no ordinary destination. This is where the universe's deepest secrets are hidden, waiting for us to uncover them. As we approach the event horizon, the ship's speed increases, approaching the speed of light. With each passing moment, our mass grows, and the energy required to maintain our velocity escalates exponentially. Our ship's systems are under immense strain, pushing the limits of relativity itself. Yet, ahead of us lies the black hole singularity, a point of infinite density. Time itself seems to warp around this place, creating a paradox that no equation can fully describe. We are caught in the collision of two infinities, the infinite speed of our approach and the infinite density of the singularity. But we're not stopping. We're about to make a bold move. We edge closer to the event horizon, and our ship's energy is carefully balanced. The gravitational potential of the black hole pulls us in, while our warp engines maintain the kinetic energy needed to avoid being swallowed whole. Every decision, every calculation is critical. At this moment, our relativistic kinetic energy and the gravitational pull of the black hole are perfectly aligned, creating a delicate equilibrium. If we can harness this balance, we might have a chance to escape the black hole's grip, using the very forces that threaten to consume us. As we push forward, the ship begins to feel the effects of space-time distortion more acutely. Time slows down for us, but from the outside, it seems like we're frozen in place, stuck at the edge of the event horizon. The temporal coefficient increases, showing just how much space-time is warped around us. But what if this is our key to escaping? If we can manipulate this distortion, use the curvature of space-time to our advantage, we may be able to break free. It's a gamble, but it's the only option we have left. If we time it right, we could gain enough energy to escape, and maybe even do the impossible. We push the limits of our warp drive. The ship is now nearing the black hole's event horizon, but we're about to take a bold step, something that challenges everything we know about physics. What if, just beyond the edge of the event horizon, we could relax the constraints of Einstein's theory of relativity? Could we achieve faster-than-light speeds by manipulating space-time? If we use the extreme conditions near the black hole to bend time, could we break through the speed of light barrier? This is no longer just a thought experiment. It's a race against time, literally. We enter the heart of the slingshot maneuver. With precision, our warp ship loops around the black hole, using its gravity to accelerate to unprecedented speeds. It's not just gravity that's pulling us in. Our engines are absorbing the energy of the black hole's space-time curvature, propelling us faster than we ever thought possible. As we skim the edge of the event horizon, our ship's velocity shoots up, our energy surging beyond any normal threshold. This is the power of the black hole's gravity, a force that's been harnessed in a way never before imagined. The energy we gain from this slingshot effect might just be enough to push us past the light speed barrier. Even as we break free from the black hole's gravitational grip, we know that the universe is still at work, balancing energy on a cosmic scale. We pass through the realm of black hole thermodynamics, where Hawking radiation, the quantum process that causes black holes to lose mass, continues to operate in the background. Though we've escaped the event horizon, the black hole itself isn't eternal. It slowly evaporates, releasing quantum radiation as it does. This cosmic balance is crucial to understanding the life cycle of black holes, but it also highlights the energy that's being transferred out of the black hole, even as we move farther away. Our journey through the black hole's gravitational field has opened new possibilities. We've broken the speed of light barrier, but this is just the beginning. If we can control these extreme conditions, these distortions of space-time, what other breakthroughs could we unlock? Could we manipulate gravity to achieve even greater speeds, or perhaps use these forces for entirely new forms of propulsion? The black hole has pushed us to the edge of physics, but as we push forward, we realize the future of space travel and astrophysics is wide open. The possibilities are only beginning to unfold. As we escape the black hole's influence, we look back at the event horizon, a place we once thought of as an impenetrable boundary. But now, we know better. In this new realm of faster-than-light travel, everything we knew about time and space has been redefined. Could particles have escaped the black hole at superluminal speeds? Could this be the key to understanding how we can move beyond the limits of relativity itself? What was once thought to be impossible is now a new reality, a frontier where the laws of physics bend and break, offering new horizons for the future of space exploration. As our warp ship soars through the stars faster than light, we realize that the black hole, once a terrifying force, is now a tool in our quest for the ultimate understanding of the universe. This journey has taken us beyond the edge of known physics, pushing the boundaries of space and time. What lies ahead we cannot yet know, but we're on the brink of something extraordinary. I hope you enjoyed this program. Please show your support for my channel by clicking that like and subscribe button. You can also order my book, Tachyon Drive, Faster Than Light Travel Within Special and General Relativity. This book is your gateway to an exhilarating journey into the cutting edge of theoretical science. This groundbreaking collection of ideas extends the genius of Einstein's theories, unveiling bold solutions for breaking the cosmic speed limit. By delving into the very fabric of space-time, Tachyon Drive explores how tachyon particles, hypothetical entities that exist beyond the speed of light, could become the cornerstone of interstellar propulsion. Imagine a beam of these particles, propelling spacecraft to traverse the vast cosmos at speeds we've only dared to imagine. Tachyon Drive, Faster Than Light. Travel Within Special and General Relativity. Available now on Kindle. Join the journey beyond the speed of light and into the future of exploration. Link in the description below.